Hi, my name is Nigel Griffiths. I work in the Advanced Technology Centre in the UK, part of IBM Europe. In this Back to PowerBasics movie, we're going to look at dynamic changes to logical partitions. That's while the operating system is running in the logical partition, we're going to change the amount of CPU time, we're going to change the amount of memory, and we're going to add physical adapters to the running operating system. Here's my logical partition demo. It's the only thing running on this four-way machine. We can see it has 2 CPUs and 4 GB of memory, and I started the profile here called dedicated. That's just a name. It's to remind me that this profile has the dedicated regular CPUs in here. And we can see the 2 CPUs here not doing everything. Now I'll quickly start a fake workload over here to keep our CPUs busy, and we can see some effects as we go. We'll just watch that for a couple of seconds, and we can see that these little programs that I'm running are keeping this logical partition pretty busy. I mean, we might be worrying that this is performing very well, because there we are, we're hitting the 100% CPU busy. So let's do some dynamic logical partition changes. We've got processor here, memory, physical adapters, so there's slots in the back of the machine, and we have virtual and the host Ethernet adapter. Now we'll look at CPU. We can add or remove CPUs, or we can move them. That just means remove it from one logical partition and add it to the next. So in our case, we want to do add. We can see that we've been assigned 2 CPUs, as in our profile, and the minimum and maximums are set to 1 and 4. Of course, we can't go below 1 CPU. We have dedicated CPUs, they're either all in the CPU or not. But we can limit to the maximum if you wanted to. In this case, let's just go straight to the 4 CPUs. I'll bring up the console here, and we'll OK that. There we go, we can see the 2 extra CPUs have been added to our logical partition, and the performance looks a lot better here. We've got some idle time, so we know that we can hit the user response time. Now we could do that all day long. It was fairly easy, wasn't it? Processor add or remove. Let's take it back down to 2 CPUs. Bring up the console again so we can watch it happen. 1, 2, back down to 2 CPUs. Now let's shut that workload off, and we'll show memory on this machine. Here we have the 4 GB of physical memory, and we'll do a logical partition dynamic memory add. Here the minimum and maximum are 1 and 6, and we currently have 4 GB. If I put in, say, 8 in here, this is above the maximum, we'll actually get an error saying no, we're not allowed to go that high, because our maximum set for our logical partition is 6. So let's go up to the 6. Bring up the console again. We'll OK that. Now this does take a little bit more work in the machine. We can see here the memory being added chunk by chunk up to the 6 GB. Now if we're removing memory from a logical partition, in this case the memory would be unused, so we could quickly take it out. But if the memory was used, there was valid pages in the memory, then the copy of AX would have to page that out onto the paging space to free up the memory to actually then let it be deallocated and taken from the logical partition. So that can take more time, and it will actually produce a performance hit when we actually do that operation, because as we know, paging slows down our machines. Let me remove this and bring in a larger console. Here we go, so we can read the writing clearly. We'll just look at the adapters in our logical partition here. We have a virtual serial. This is our console that we're just using. We have some disks connected to our SAS adapter here, actually on the planar of the machine. Then we have the logical host Ethernet adapter and port, so this is the network we're using. Now if we do a dynamic processor physical add, and we get here a list of the adapters in the machine that are not assigned to a logical partition. So let's give ourselves a Ethernet controller and fiber channel adapter as well. But that's enough for now. We'll just OK that. Okay, if we go back to here, we do ls dev again. We can see informed that these things have arrived and has brought them online. Here's our fiber channel adapter. New Ethernet adapter is actually a 2-port Ethernet adapter, so we see 2 ports here already defined. We can run the config manager command to actually bring those online and start using those immediately. If we were removing those from our logical partition, we'd have to use rmdev command to remove them, so that AIX is no longer aware of them, and then we can actually remove them from our logical partition. Next, we'd like to show what happens when we got a shared processor partition rather than a dedicated processor partition. So the first thing I have to do is shut down. We'll do an immediate here, saying it's not recommended, but it's a demo system, and no, we're not replacing a battery. We'll see here that the codes have changed. We've gone to shutting down. We're not active, so let's start it up again. Normal instead of dedicated. Starting up again. Propeller here means we're reading the disk. AIX kernel's been read in, starting up. And we're up and running. Now if we do dynamic logic add or remove, we'll see the options are different here. In this profile, the minimum was 1 CPU and the maximum. Immediately notice that we have fractions of a CPU here. And I could change this to something much finer, something like this, take it down, quarter of a processor. The virtual processor numbers tell us how we're going to spread out this amount of CPU time across our CPUs, so that 1 3/4 CPUs can be spread across 3 CPUs. In fact, AIX will decide if that's good or not. If it can use less CPUs, it will. It gains a little bit of performance when it does that, but we can change that dynamically as well. We can also go uncapped, in which case we can go over this assignment here now and borrow CPU cycles if they're free. And the weight factor is that when more than one logical partition wants to go over its assignment, then it decides which is more important, and you'll get the CPU cycles based on the ratio of your weights. Won't actually do that today.